Mhm. Good morning, students. So, in the Cryptography Network Security lecture series, from the today's topic, we are going to discuss from the Unit 2, that is block cipher modes of operation. So, it's going to be handled by Logesswari from RMD Engineering College, working as an assistant professor in CSE department. So, let's move on to the session. Okay. So we have modes of operation. So we have two different types of ciphers. One is a block cipher, next one is a stream cipher. Block cipher is that we are going to encrypt the data in the set of a block. But what about stream means we are going to encrypt the data each and every bits. So that is said to be the stream cipher. Okay. So in the block cipher we have five different modes. So first one, basically it is a very important mode which is called as the electronic code book mode, ECB. Here that message is broken into independent blocks. So each block is a value substituted like a code book. So and each block is encoded independently with the other blocks. So it is used only for the single value. So this is a formula. In this way we will do the encryption, that is ciphertext is C of I is equal to E suffix k of Pi. So this is the diagram. Here in this diagram, in the first iteration, here you can see that the large plain text, like if I have 64 bits or 34 bits, 32 bits, I will divide the data into a part of data. So divide into an equal parts, and then I will take only the part of the data and do the iterations and do the encryption and all. So here in the first phase, plain text, that is P1, I'll do along with that encryption. It's a simple one. I'm just using the key. Here you can see that I am going to use one common key. I'm not going to use different key. That is I'm going to use only the one common key. So in this way I am finding out the ciphertext 1, 2 and 3. Likewise for the decryption, C1 of decrypt of K, and then in this way I am getting the plain text. Okay. Advantages and limitations of ECB. So in this, advantages are message repetitions are shown in the ciphertext, and then if the message if aligned with the message blocks, so and then weakness is due to encrypted messages are being independent, as well as it will be used only for the few blocks of data. We can't able to use it for the large amount of data. Another disadvantage is that you are going to use it only for the same key is going to be used here. Next one is the cipher block chaining mode. So in this, the message is also is going to be broken into parts and then linked to each other. So here the output of the previous cycle will be given to the input to the next one. So each previous cipher blocks is chained with the current plain text block. Hence the name, with the help of the initialization vector IV to start the process, C of I is equal to E suffix k Pi XOR of Ci minus 1. So Ci minus 1 is the initialization vector. For the very first time, I will be using initialization vector for encryption. For this further coming cycles, I will be using the output of the first one will be given to the input to the second one. Uses the block data encryption for and authentication. So you can see this is a diagram. So I have given the IV for the input and XOR it with the plain text. IV and the plain text has to be XORed, and then it will be encrypted with the key, and then the output will be given to the next phase. So this is said to be the cipher block chaining mode. Likewise, we will be doing reverse process will be done for the decryption process. Next one is Next one is message padding. So message padding is that if your data is lesser than the particular block, means we have to pad some zeros in order to make a correct length. Say for example, if this electronic feedback mode or cipher chain blocking mode will work only for 64 bits now, you have to make sure that your text has to be of particular length. If it is not so, you have to append some values over there. So that is said to be the message padding. Generally we will be append only zeros to extend the length. We won't use ones. Okay. Advantages and limitations of CBC. So advantages comes to the part a cipher block depends upon the all blocks before it. Any change in the one block affects all the blocks. Which limitations are which needs an initialization vector which should be known to only to the sender and the receiver. It should not be compromised. So that is the main limitation. Next one is that stream boards of operation. We have CFP, cipher feedback mode is there, output feedback mode is there, and counter mode is there. Cipher feedback mode. So here the message is treated as a stream of bits and added to the output of the block cipher. The result is feedback to the for the next stage. Here you can use the stages of two. It will work for the number of bits like 1 bit, 8 bit, 64 bit, 128 bits to be the feedback. Most efficient use to use all the blocks are 64 and 128. Ci is equal to Pi XOR of E suffix k and Ci minus 1. For Ci minus 1 I will be using initialization vector. So this is the working concept. S bit, that is depends upon the bit how many bits we are using. If I am going to use 8 bits now, S bits will be 8 bit cipher feedback is there. So as you can see, first I will be using initialization vector and encrypting those process, and then along with the S bits I will be selecting only the part of the S bits and the remaining bits will be discarded, and then I will be taken the part of the S bits and then XOR with the S bits, and then in this way I am producing the value. So in this way that encryption will be done here. Okay. Advantages are appropriate when the data arrives in bits and bytes and most common for stream modes, and then it will be errors will be propagated after if there is any error. Next one is the output feedback mode. Here also the message is treated as a stream of bits. The output of the cipher is added and then the output is then feedbacked. The feedback is independent of the message. O of I is equal to E suffix k of Oi minus 1. Ci is equal to Pi XOR of Oi. O minus 1 is equal to IV. So this is the diagram pictorial representation of output feedback mode. So here you can see that here itself the output of the first stage it will be given to the input. So we won't wait for the final ciphertext. We in between itself we will be we will be sending the output to the next phase. So advantages are it needs an IV which should be unique. Bit errors do not propagate here. Most vulnerable to the message stream modification should be in the sync. They should be in the synchronized. Next one is the counter mode, which is an OFB but encrypts the counter value rather than the feedback value. OI is equal to E suffix of I. Ci is equal to Pi XOR of OI, which will be used for very high speed network encryptions. So same as it is here also, but what we will do, we will use some counter values. This counter value is going to be different. Instead of IV, I am going to use the counter value for each and every iterations. So the advantages are can do parallel encryptions in hardware and software, can process in advance of needs, good for bursty high speed links and random access to the encrypted data blocks. So thank you students. So these are all about modes of operation. Thank you.